Plotting equations, reading and plotting equations, and making equations from tables. That's what we're going to knock out today, is making equations from tables. So just to go over the basics of the stuff that we've gone over before, slope is how slanty the line is. We can have a positive or negative line. This would be a positive line, and this would be a negative line. We read lines from left to right, just like you would a book, and top to bottom. So left to right, top to bottom. Sloping down is negative. It's decreasing. So the thing to remember is the change in y over the change in x, which is known as your rise over your run. That's going to be your slope. And we're eventually going to get into why that's backwards. Instead of it being x over y, in the order that ordered pairs go in, everything's x, y, and then we start dealing with slope, and it's y over x. And the y equals mx plus b, your b is your starting point or your y-intercept. And then that's when we would count. And we make a positive slope. So also something can be referred to as y is your output value, which means that whenever you substitute an x value into an equation, your input, and you solve it, you're going to end up with y equals a number. That's why it's an output. Whenever you put an x value in, you end up with a y. So just to re-emphasize the things that we did, we talked about going from one point to another, counting how far up and over we had to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was our change in y, a positive 10. And then over 1, 2, 3, 4, 5, 6. We can simplify 10 over 6 because 2 goes into both. So that's 5 over 3. That's going to give us a slope of 5 over 3. So I'm going to use a different color. 1, 2, 3, 4, 5 over 1, 2, 3. You can see we hit our y-intercept there, which is 0. So the idea behind this and being able to look at a line and write an equation, find the slope, find the y-intercept, etc., is to be able to identify those parts to put it into the equation. So one thing you left out on your work was writing the equation, 5/3 x plus 0. This needs to be written. This is a very crucial part of what we're doing. Just to go over it again, because it was incomplete, we counted from one point to another. I'm just going to go ahead and circle it's a positive line. Our y-intercept is right here, because that's where it's crossing the y-axis. So I'm going to put -5. We can already put -5 down there. Slope, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 10, so that's positive 10 over 1, 2. Those are both divisible by 2. We can simplify 5 over 1. We can do 5 or 5 over 1. They're the same thing. What you're going to see as an equation given to you is this, 5x minus 5. That needs to be written. If you want to put 5 over 1x minus 5, perfectly fine too. Again, re-emphasizing. So positive line. Let's count the distance. And I left this one on here because it's crossing through the middle, and I just wanted to tell you again that if it's crossing through the middle, we're not there yet. You know what? Then let's focus on the slope, okay? Because this is going to be the main part in what we have to deal with. So up 1, 2, 3, 4, 5. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This can be simplified by 5. That'll give you 1 over 2. Your slope is 1/2. And we can double check that by going up 1 over 1, 2. There was a point. Up 1 over 1, 2. There was a point. Up 1 over 1, 2. There's a point. So cool, it checks out. So we would have at least y equals 1/2 x. And the way that this is being done right here on this particular problem is going to be very beneficial for what we're doing today. I wanted to throw a -1 in there as well. So we went down 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went down 2 and we went over 10. So negative 2 because we went down 2. It's divisible by 2. We can simplify 1 over 5. So we have negative 1 over 5. Okay. And we can see it's crossing through at negative 2. And we can verify that by going 1 down and 5 over. 1 down, 1, 2, 3, 4, 5. Check. Okay. So negative 2. So there would be your equation. Negative 1/5 x minus 2. You identified those parts, but you didn't write the equation. And the only reason I'm going over it again is because you didn't write the equation, and I want to show you the equation, because today we are writing equations. Like, that's the only thing we're doing. So what we did last time was we talked about the parts, slope and y-intercept. And I told you that there was going to be substituting in. Okay, so today is going to be the third part. And you're going to see how these are all tying together. So if we use this, what we did last time was we had a point at positive 1, and we used the slope. The slope was 2, which makes it 2 over 1. Up 1, 2 over 1. 2 over 1. And we made a line. We identified if it was positive or negative. That's all we did. And then I would say, hey, just for future use, you're going to substitute these numbers in. So it'd be 2 times 0 plus 1, which is 0 plus 1 is 1. And then I would say, hey, look, that's our y-intercept. Whenever x is 0, that's your y-intercept. And then 2 times 1 plus 1, which is 3. And I go, hey, look, that's increasing by 2. Look, there's our slope. It's plus 2. What we did last time is, so you can see here, we made the line last time. Then last time, we were given the line, and we were supposed to find the slope and y-intercept. So this was not given, and we had to do what we just went over, like 4 or 5 problems. All right, so from dot to dot, we had to go up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. Those are both divisible by 4. We can simplify, just like I sent you that message back saying, hey, you need to go through and simplify these. 2 over 1. Okay, so there is our slope, and where is it crossing through? So let's go ahead and do our simplified one. 1, 2 over 1. 1, 2 over 1. At positive 1. So we have that was the part we left out. And we can also write that as, the way you will see it is this. These are the same. Okay, and just to go back and look, that the line that was graphed is actually 2x plus 1. So you can see how all the pieces are tying together. Now, what about writing an equation from a table? So we made the line from an equation. We use the line to make an equation. Now, what about if we don't have a line, we're not making a line, and we're only given coordinates? There's 5 steps, and this is going to be the same exact procedure every single time. Like, that's not going to change no matter what problem you're given. If you're given coordinates, this is what you do. What is y changing by? Here's what that looks like. What's y changing by? Plus 1. What's it changing by? Plus 1. What's it changing by? Plus 1. So you can see already that your rise is 1. There's your change in y. I'm just going to put a 1 right there. 1. What's x changing by? Plus 1. Plus 1. Plus 1. For today, the idea of going through this procedure is going to be emphasized in a very simplistic way. This is going to get slightly more complicated, but it's not going to be anything that's out of the ordinary. It's just going to be a fraction, and you're going to have to simplify. That's how much heavier this gets. So really, we have a fraction 1 divided by 1, which equals 1. Okay, so we have 1x. use your slope to sub 0, 1, and 2 into your equation. All right, so far we have y equals 1x. So y equals 1 times 0. That would be 0. But does y equal 0? No, it equals 1. Well, okay, so then how would we get to 1? Plus 1. And let's just verify that. So this would be your new equation that these coordinates make up. What do you add or subtract to make it match? We added 1. All right, so let's see. Y equals 1 times 1 is 1. Well, what does, when you sub 1 in, it should say 1 right here, but it doesn't. What do we have to add or subtract to get there? We have to add 1, and that's what it equals 2. Boom, checks out again. Let's try with y equals 1 times 2. That's 2. So when we substitute in 2, we should be getting 2. That's not the case. But what do we need to add or subtract to get there? We plus 1. So we have an equation of x plus 1, or 1x plus 1. These are the 5 steps you're going to go through over and over and over. And I'm going to go through 4 or 5 of these using those 5 steps over and over and over. Those 5 steps will be recycled. So I have the equation covered up. You can see that there's no line, but there are coordinates. Now here's 2 options. You always have the option of plotting the line using the coordinates. And I'm just going to go through and do that. The idea that we're doing today is not this. But if you're sitting there going, why can't I just plot the coordinates? Well, the answer is you can. Okay. Wow, that line's way off. Okay. So you can see that we have a negative line. All right, so it's going down by 1, 2, 3 over 1. Okay, where's it crossing through the y-axis? At positive 3. Okay. I'm just going to show you that's what the line was. Okay. So now clearing all this off and us going back, let's follow the procedure. What's y changing by? What's y changing by? Looks like it's going from 3 to 0. That's minus 3. 0 to negative 3, minus 3. Negative 3 to negative 6, minus 3. So far, our change in y is negative 3. What's this changing by? Plus 1. Plus 1. Plus 1. And the reason I'm doing this is I want to make sure it's consistent. Because if it was, say, plus 1 here and then plus 2 here, I would have to look and try and determine what's going on. That's where another complicated part's going to come in, but we're not doing that today. So there's my change in x. Boom. All right, so far we've got y equals negative 3x. Now all we have to do is substitute 0, 1, 2, 3 in to what we just wrote. We're on step 4 already. Y equals negative 3 times 0. Negative 3 times 0 equals 0. So when we substituted 0 in, the answer we got was 0. Step 5 says, what do we add or subtract to get there? To 3. Well, we just add 3. 3 plus 0 is 3. So far, this is our equation. We're going to test it out again. Y equals negative 3 times 1. Negative 3 times 1 is negative 3. We substituted 1 in, and that means we should have gotten an output value of negative 3, but we didn't. So how do you get from negative 3 to 0? Plus 3. That's where it's coming in, over and over and over. All right, so I'm going to do 2. Y equals negative 3 times our x value of 2, which is negative 6. So when we substituted 2 in, we should have gotten a value of negative 6, but we didn't. So what do you need to add or subtract to get there? Well, negative 6 plus 3 is negative 3. That's why we've got a plus 3 right here. So what we're doing right now is we're verifying our information. We're checking. Y equals negative 3 times 3, which is negative 9. So we substituted an x value of 3, and it said that we should have got negative 9, but we didn't. Step 5 says, what do we add or subtract to get there? Negative 9 plus 3 is negative 6. Awesome. So the most correct equation would be negative 3x plus 3. And I want to show you that that's what we got from the very beginning. Negative 3x plus 3. Okay, so I plotted it at the beginning, and we didn't need to plot. But I wanted to show you that you do have another avenue. And I want you to understand how to create the equation from a table. Okay, if you want to pause it and you want to take a moment and try and do this one on your own, fantastic. Highly encourage you to do so. And if you can only get through the first couple steps, that's perfectly fine too. So try and find your change in y and your change in x, and then set it up and put x next to it. Okay, so step 1 says find your change in y. Negative 3 to negative 2 is plus 1. Plus 1, plus 1. All right, so far our change in y is positive 1. Plus 1, plus 1, plus 1. Cool. So right now we have y equals 1x. Now, we just went through what's the change in y, what's the change in x, steps 1 and 2. We set it up as a fraction, and 1 divided by 1 is 1, so that was step 3. Step 4 is substitute your numbers in and see if it equals the y value. So we're going to use this that we just made and substitute x values in for x and see what y equals. All right, so 1 times 0 equals 0. Well, what was 0 supposed to equal? It was supposed to equal 0, but it didn't. So how do we go from 0 to negative 3? Minus 3. Now let's see if that works. We have 1 times another x value of 1. That equals 1. When we input 1, it said we should have a y value of 1, but it says negative 2. How do you go from 1 to negative 2? Minus 3. Cool, it works. Let's triple check. 1 times 2 is 2. So when I put my x value of 2 right here into my equation that I wrote, it said it should have given me a y value of 2, but it didn't. So how do I go from 2 to negative 1? Minus 3. Just to be thorough, 1 times 3 is 3. So when I put my x value of 3 into the equation that I have highlighted up here, 1x, 1 times 3, it should have been 3, but it's not. It's 0. So what do I add or subtract to get there? Well, 3 minus 3 is 0. There's the minus 3. Perfecto. All right, so let's just see if we got this right. X minus 3. And remember, anytime that we have a variable and nothing in front of it, there's always an invisible 1. If you wanted to plot them, all of this information would check out. 0, negative 3, 1, negative 2, 2, negative 1, and 3, 0. Okay, we have a y-intercept of negative 3, check, and we go up 1 over 1, up 1 over 1, up 1 over 1. There it is. Try this one on your own. Hit pause on the video. See if it all makes sense. The graph has nothing to do with this today. I'm just showing you that the information that we're generating does work. And I'm also putting part 1 and part 2 together into part 3. Whenever we do part 4, it's going to be 1, 2, 3, and 4 all together. So step 1 said find your change in y. Negative 1 to 2 is plus 3. 2 to 5 is plus 3. 5 to 8 is plus 3. And the only reason I do this all the way down the table is to make sure that my data is consistent. Because if these numbers are different, then I have to look at something else. And that's where we're going to get into the upper level part. We're not doing that today, but I'm just going to keep on saying it. And then the change in y. So we got 3. Look at that, plus 1. Just making sure it's all plus 1. Okay, 3 over 1. So right now we're looking at y equals 3x. Now step 4 says to substitute those numbers into what we just came up with. And I got the 3 from right there. If you want to put 3 over 1, that's perfectly fine, but it's the same thing. 3 divided by 1 is still 3. So now I'm going to substitute x values in for x. So y equals 3 times 0. 3 times 0 is 0. Okay? So whenever I substitute 0 in, it said it should be 0, but it's not. So how do I get to negative 1? 0 minus 1 is negative 1. Okay? So minus 1. Now let's see if it works. Y equals 3 times 1, a new x value of 1. Put right there. 3 times 1 is 3. How do I get to 2? Minus 1. Check. All right. Y equals 3 times 2. So whenever I put the x value of 2 in, it said it should be 6, but it's not. It's 5. So how do I get there? Minus 1. Y equals 3 times 3, which is 9. So I put this 3 in for my equation. It said I should have gotten 9. But it's not. It's 8. So how do I get there? Minus 1. That's where that's coming in. So the questions I'm asking out loud are the questions you have to ask yourself. That's why they're the 5 questions. And there is our answer, 3x minus 1. To plot it, you can see 0, negative 1, boom. There is our y-intercept, which is why it's minus 1, which is why 0, negative 1. 1, 2. And then you can see how it's increasing by 3 because we have a positive 3 slope, up 3 over 1, up 3 over 1. These are all going to become patterns that you'll be familiar with. Okay, so I wanted to throw this one in to just show you an alternate way to use the table because I don't want to mess with 10 thirds and I don't want to mess with 8 thirds. So whenever it comes to this, you could go like this. What's it changing from 4 to 2? Minus 2. Okay, and then that means we'd go from the corresponding x values that we chose for our y's. How's it going from here to here? Plus 3. We put that on top of each other, and we have our slope. Okay? So we know that when x is 0, we have our y-intercept. It's right here. Check this out. So there's all kinds of ways that we can go about using the table, and this is going to be an upper idea. We will not do this for the work today. We're going to do what we did on the previous problems. Repeat the process over and over and over and over. So this is what your assignment's going to look like. It's going to be a PDF that has 9 different pages. Each one has a different problem. I want you to use steps 1 through 5 and actually write an equation. So you should have 1. What is the change in y? 2. What is the change in x? 3. What is the change in y over the change in x? That equals your slope. Then you put an x next to it. Okay, and then you will have an equation. So an example would be 2 over 3x, 2/3 x. Then you'll sub all your x values in, 0, 1, 2, 3, and solve. So for example, 2/3 times 0 equals 2/3. Then you ask yourself, what do I add or subtract to get y? And you're going to be looking at your y values to make it get there. Okay? Now, the 2/3 is just an example. It has nothing to do with this problem. I'm giving you an example. So then you would have 2/3 x plus 3. And all of this stuff should be shown on a sheet of paper. No steps should be skipped, nothing. If any steps are skipped, I'm going to send it right back to you and say this needs to get done. All right? And if you want to chat and go over a couple of them, I will create some examples. I really do want you to solve this puzzle. Think of it as a puzzle, and let me know if you'd like to meet and chat about it.